Well, good evening, everyone. Hey, I'm really glad to welcome everybody to our uses webinar session on battery storage and safety for New Yorkers here that are experiencing solar energy in their communities. My name is Maz Trieste. I'm with Uses. I'm a founder and on the board of an amazing group of folks that are set to help educate everyone about solar energy in New York and elsewhere. We have been involved since probably January last year. We started to grow, and recently we obtained our 501c3 not-for-profit status. So we're fundraising to keep uses alive and going so we can continue with these wonderful educational efforts. I have actually, this is our 8th webinar that we've held. Due to COVID, we obviously can't get out into our communities as we really would love to be able to do, but it's been helpful. We have a lot of folks that have been really interested in solar, and coming onto our webinars has been pretty successful. So I welcome you all here tonight. I just want to give a shout out for Uses, just so folks know about what we do. Eva Hoskins was with us, and she helps in a big way with our Uses efforts as an intern. We have a nice website, and you can get to it by going to usesny.org or usesusa.org. And we have, this is our wonderful website. We've collected a lot of information, current information about solar energy. I'll just show you the basis of what we do. And the educational piece is, I think, where a lot of people will find all this information about what we're really focusing on, the issues involved with agriculture and jobs, and wonderful opportunities for municipalities throughout New York to grow solar energy, big and small. We do highlight a lot of the bigger, broader utility-based solar projects. So this battery storage and safety webinar is really super timely for that, because a lot of these projects are going to be using utility size battery storage components. And being on the ground, we've been noticing a lot of and listening to a lot of folks misunderstandings or concerns about battery storage. So we really need to have the word get out there quickly. NYSERDA is, of course, helping in a big way to do that as well. So I really want to make that clear, that we're all trying to partner in ways to get the right information out as quickly as possible. So battery storage and safety is key to successful solar development in New York and elsewhere. So we have two incredibly wonderfully equipped people with us who understand the ins and outs of battery storage. And I'm going to introduce them shortly. But before that, I just want to say this is going to be, this is recorded. So everybody who's listening to this will be able to listen to it again, and will be on the Uses website. We will be taking question and answers after each of the presentations, and then, between the presentations, and then again at the final presentation, so that people can think about questions, put them in the chat, and then we'll try to get to as many of those as possible. We'll break in between the presentations to try to get to some of the questions. And then those questions we don't answer, we'll try to get those answered and place them with answers on our website. So you all should hopefully get a lot out of this. For those of you who need training certificates, Eva is with us, Eva Hoskins, as I mentioned, and she will be the person that you will want to contact. Eva maybe will not want to say something to this, but to get your certificate. We do require that people stay on for the full time. Eva, you want to let them know how to do that, please?
Yeah, so once and we do ask that you stay on for the full duration, so that obviously you get the credits for what you did. And you can just email usesny@gmail.com, and I will email out your certificate. Thank you.
So great. Let's just get right to it. I don't think I missed anything else as far as kind of like housekeeping, but like I said, just keep your questions going in the chat, and we'll try to get to them as best we can during the 90 minutes here. So our first presenter is going to be Mr. Paul Rogers, who's this wonderful retired FDNY lieutenant, ESS subject matter expert. So his work included emergency response development and code and standard advisory, to name a couple. And Mr. Rogers currently sits on the following codes and standards as an active committee member: NFPA 855, Energy Storage System Installations. It's an Underwriter's Laboratory Standard 9540A, and IFC, International Fire Code Action Committee, Chapter 12, ESA Advisory Team, the US DOT, FAA Lithium Ion Battery Safety Advisory Committee Transportation Task Force. And upon retirement, Rogers was hired as an advisor to NYSERDA and SUNY DG HUB, an emergency operation response and code enforcement training. So this is the guy you and anyone who's concerned about, fire hazards in and around batteries, he's the one you want to talk to and ask questions of. So I really look forward to Paul's presentation, and then we'll get to the next after Paul's. I'll introduce Mohammed shortly. Thank you, Paul. Welcome. Thanks for doing this.
Thanks, Mace. Hey, hi everyone. Let me just get set up here. Okay, can everyone see? Mace, can you see me up there?
I see you up there, Paul. You perfect.
So as Mace had said, I back in 2013, I was working in the New York City Fire Department, and I was working in the field, and I was told to go down to a meeting down in headquarters to sit in on energy storage systems, which I had no idea about at that particular time. So I knew very little about any of this stuff when I first started. But I asked a couple of questions at a meeting, and the next thing you know, they said, thanks for taking over the project. And that's how I got involved with energy storage. So anyone in the military can appreciate that. Actually, I was voluntold. So as we know, there were some challenges within New York City, very dense population, and we started to get a little bit concerned about, what do you mean energy storage? How does this actually work? And they started to explain some of it. And we already knew that we had some batteries inside of the buildings in New York City, and they were batteries that looked something like this picture over here. And they were backup batteries in the event that the grid went down, and they were all lead acid based. And we said, okay, so we do know that these things already exist out there. And, being that I was working in our hazardous material unit, I would be sent to any one of these things that went on, had any type of issues. And honestly, there were very little issues with these things, but then they really didn't get cycled much. So they weren't on much at all. So I wasn't too concerned at first. And then we started looking at the code and what the code said. And the code at that particular time, the code that you see on the screen here in New York City, was developed from the New York State code. And then they added their own little piece into it to make it a little bit stricter than what New York State has. But it really didn't cover batteries the way that they wanted to use them. So the application that they wanted to use them there wasn't really covered sufficiently in the codes. And we knew it. And we realized that, hey, this could be an issue. But again, we felt pretty comfortable with the lead acid batteries and other chemistries that we felt we knew about. But we didn't really know much about the lithium ion. So we started to ask some questions about that. And some of the questions that we asked, some of the people that were trying to install these batteries into our location really didn't come up with answers that we felt was sufficient. So we wound up going and speaking with Con Edison and NYSERDA, and we asked them, we said, look, would you mind if you started to do some work and get us some answers on the lithium ion batteries, because we're not really familiar with them. So they both were very good, and they said, yeah, we will. And for those who don't know, Con Edison is the local utility that supplies energy in New York City and Westchester. I believe they also go up in Rockland County, but they were good because they wanted to get these batteries in there. It was going to help them with their energy transmission and other stuff. And NYSERDA, which really is trying to push the renewable energy within the state of New York, they also were very interested. So they said, okay, yeah, we'll do that. We'll wind up putting some money together, and we'll look at what happens when these batteries fail. Because we don't know. And as I said before, we weren't, the people that were talking to us, they didn't give us what we felt was sufficient answers. And I'm going to be honest with you, in the beginning stages, there were some people who was saying that these batteries will not go on fire. So we were a little skeptic of that, and we found out differently. So what we did is they hired a company, NYSERDA went out and hired a company called DNVGL, and my colleague who will be following me up after this is going to talk more about this particular report. But this report was the first of its kind, and really what it did is it started to show the hazards that were involved with the lithium ion batteries as they went on fire. And guess what? They were on fire. So we said, okay, now that we know the hazards, how do we start to protect against them? And we started to look in on how we're going to protect against them, because the codes were not sufficient out there at that particular time. But, you know, with fires and toxicity, you know, in the regular fire operations, we deal with that on a regular basis. You know, matter of fact, almost every day, someone in New York City is going to some sort of fire, and there's always toxicity involved. There's that high heat. And then you got some flammable gases that, you know, that also came out of this report. And I think the big one that we really were concerned about was the stranded energy. So even though these things went on fire, they still had that energy. And that was a concern that we said, that, you know, that energy doesn't dissipate, or we can't dissipate that energy if there's an emergency, right? You cannot just start to push that energy out of the batteries. So that became a little bit of a concern for us. So next, we looked at these, the different applications on how they're going to be used. And we looked at the cycling frequency of these things, right? And all these things that people who are not familiar with, there's all these different ways of using batteries. But what we really were concerned about was really how often they would be cycled. And, you know, common sense started to come in here where we said, well, if they're going to be cycled frequently, maybe there's more of a chance of these things actually failing. So we wanted to look at, again, go back to what the code said. And the codes were really covering this particular area here, not cycle frequency, like emergency life power, emergency fire for life safety, things like alarms in a building. If the grid were to go down, we want to make sure those alarms continue to work. So those batteries, as I mentioned before, on the lead acid side, were all over the place. They were everywhere in almost every single building that you went to, because everyone had some sort of fire alarm. So again, we started to realize that, okay, they're out there, but they're not in the lead, they're lead acid base as opposed to the lithium ion. So we looked at the application, and we just felt that the codes were not relative to the application that they were trying to use these batteries for currently. So the next thing we wound up doing in the fire department of New York is that we started to grab some partners. And we wound up going to the federal agency, U.S. Department of Energy, and asking them what work have they done on lithium ion battery? Has the military done any work? Has the Department of Energy done work? Who has done some work where we can start to use some of the information that's already done? Again, we used NYSERDA, and they were very helpful on trying to get us answers. So we were really appreciative of that. But what I started to do is I started to reach out to people in Underwriters Laboratory and also in the NFPA. And for those people who don't know, Underwriters Laboratory, they're a standard development organization. If you have a refrigerator in your house and you open up the door, you'll see that there is an Underwriters Laboratory mark on the inside there showing that this product is safe to be installed inside. So we started to ask some questions, and we started to tell them what was going on. And the very first person I interacted from Underwriters Laboratory asked me to repeat what they were trying to do. And I said, well, Tom, his name was Tom Chapin. I says, Tom, they're actually trying to put these batteries into the high-rise building, lithium ion batteries into high-rise buildings, and we don't know how to get them in there safely. And he said, oh man, I have to come up and really go over some things with you. And he did. And he kind of scared me a little bit. But as I started to get more comfortable and understand these things, that whole getting scared started to dissipate a little bit. I had respect for it, but I started to realize that we can start to manage it. And the same went with NFPA. When I started to speak to people in the NFPA, a gentleman like Casey Grant, who was part of the research foundation, who would do destructive testing, I mentioned it to him. And he said immediately, we need to start to collaborate with a whole mess of people and experts around the country to try to find out what is the best way to start to move these things in. So initially we thought they were going indoors, but we decided that, you know what, let's just try outdoors first, and then eventually we'll move them on the inside. So again, this was back in 2000. By the time this was going on, it was between 2014 to 2015. So we did 2 years of investigation before we even moved any of these things. We really took our time and dragged our feet, and we really asked a lot of questions. And I have to say that most of the manufacturers were pretty good on trying to get us information. They really did try to move the ball forward. And I respect that. They were sometimes they just didn't know the answers, and or they didn't have the right answers, but I don't think that they were trying to pull the wool over our eyes. I just think that they were just trying to give us what they knew. So next we came into, my chief said, okay, listen, Paul, you're down there for a couple of years now, a year or two. And he said, I need to start to get some operations and some standard operation procedures ready for the firefighters if they were to go to a fire in one of these things. So I explained, I said, Chief, there's really none installed yet, but they're coming. He said, well, then let's start working on a procedure. So I said, okay. So for my firefighters that are in the audience, the two things that firefighters have a tremendous amount of respect for is electricity and chemicals. Well, now we combine them. These are electrochemical. So, hey, we don't throw any water on any type of electricity, and we don't use water when it comes to hazmat or the chemicals. So how the heck are we going to handle these things? So this was two of the things that the fire department, they really do shy away from, and they really have a more defensive stance on these things because they're not familiar with them. They just have a tremendous amount of respect. So it became a real big challenge. And then also, if you see, when I started using the term energy storage, I would go into a couple of firehouses and they're like, what is an energy storage? I said, a battery. And they're like, well, why don't you say batteries? And I say, well, that's a good point. So I try to keep it on layman's terms that they would understand it. So really what we're talking about here is batteries and a whole mess of batteries that are just put together to make one whole system. So some of the considerations that the firefighters, we had to start to think about this and what are we going to do? And at that particular time, there was some battery incidents that were taking place. There was one that was in Hawaii, which was critical infrastructure that burned for many days. And that really they could have done more to actually stop that, but they didn't know enough. So we realized that the fire departments just don't know enough. They don't know what to do. So that's why we need to make sure that the firefighters are trained. But I think if you had a well-trained fire department, this may have been prevented or at least mitigated early. Another incident that took place was in Wisconsin. And really, firefighters, again, lack of action. There was lack of action. They didn't know what to do. They were told not to use any type of foam or to use foam. And they waited 3 hours for a foam truck to come in from an airport, and needless to say, the whole thing had burnt out by the time the truck came. And then there was an incident that took place in Houston, Texas. And if you remember, the hoverboards were going on fire at that particular time. And I can explain that in a little bit, but I want to show you a movie, but I also have down there cell phones and e-cigarettes. So you've probably seen some of this stuff on the news, the nightly news, where they're like, oh, another hoverboard went on fire, another cell phone's on fire, and all going back to the lithium ion. So I want to show you this thing here. Take a look at this. You hear the pop noise here. You can see the smoke starting to emanate here out of the scooter. And you see this person there. Now, I'm sure some of you are saying, oh, wow, that's not good. And you probably should be saying that. But what I'm trying to tell you here is that you cannot equate these batteries to those type of batteries. The batteries that you're going to see inside these energy storage systems all have quality assurance and they're all listed. That battery that you just saw, that fire that just took place there, that was not listed. As a matter of fact, there's a big problem with counterfeit batteries that are coming over for small consumer products like the hoverboard, like the e-cigarettes and things of that sort. Or if you go on Amazon and you start searching and there's a battery involved in it, you got to ask yourself a question. Where is that battery coming from? You may see a product, right, for $17 and then the exact same product for $30. Well, you know why? Because the battery is probably, the quality assurance on the battery for the $30 is probably much better than the one at $17. So just a little bit for yourselves about counterfeit batteries, or batteries with poor quality assurance. So I want you to keep that in mind when you see that on television. Please don't equate that to the layers of safety that are involved with an energy storage system as opposed to that consumer product. So we started to look at the fire operations, and I'm really not going to get deep into this, but hey, when these things are on fire, we feel pretty comfortable with that. All we need to worry about is the stored and stranded energy. We're going to take a defensive operation. We're not saving this thing. If this thing's on fire, what are we saving? There's nothing that we can save here. There's very little that we can do. But what we want to do is, if there is a container, we want to make sure it doesn't propagate to the next container. That would be the best thing. But once these things go on fire, it's going to be hard to put them out. Our only thing is to try to make sure that the one adjacent to it, and then the codes actually cover stuff like that. And I believe my colleague will get into that. I think the challenge is going to be for fire services when they show up to the scene and this thing is not on fire. Well, what's going on the inside of that? That smoke that you just saw there, what happens if it didn't ignite? Is that smoke staying inside that container? How do they know that smoke is inside the container? There's this thing called a BMS, battery management system. And what that does is it basically continues to tell you the state of health of the battery. And it will tell you when there is something that there was a rise in temperature, and is that temperature continuing to rise? If there's a rise in temperature and nothing shows on the outside, well, rest assured there's something going on the inside there. So that BMS, which is really the eyes and ears of all safety and for the battery itself, can really be instrumental for a fire department and response when nothing is showing on the outside of that. So keep that in mind, all right? And also, we want to make sure that thing is still active, because there's going to be times when you may want to shut these things down, or you may not want to shut these things down. So there are some things where if you shut down the actual energy storage, you may lose information on that BMS. It's always collecting data. It's always checking the state of health of the battery. So here I am. Here's my big picture of my shutdown. And this is something that we learned. Hey, even though you do shut these things down, you don't dissipate the energy. The energy is isolated. It becomes stranded. And that's huge for the fire service. Whenever we have an electrical emergency, one of the things that a field communication is for the people that are on the ground is saying, hey, power is shut off. And then we start to operate. Well, with energy storage, you can shut the power off, but you did not dissipate that energy. You can stop the charging and discharging, but you did not lose the energy. So that energy will be stored there, and we call that stranded energy. And that's really important for you to understand if you are a first responder. The next thing I want to show you is this. Videos mean a lot. And as you can see, I'm not trying to scare you. I'm just trying to show you what could happen. And we can protect ourselves against that stuff, which is nice. And I'm being totally honest with you. So this is the module. So this here is going into a failure. And you see all this smoke here. This is flammable gas. And someone's like, oh, wow, look at flammable gas. Think of this being propane inside a room. What are we missing here? An ignition source. And then what? And then we're going to have some sort of deflagration. So that is a concern. And again, we recognize that in the New York City Fire Department. They recognized it in the codes and they addressed it. And you'll see as you start to go into the codes, they address how do you manage that, right? If there is an explosion, the fire service has a very difficult, they don't have any type of protection against explosions, but you can manage that explosion and make sure that the firefighters are not going to get hurt. And that can all come through information through your BMS and also engineering controls. Another concern that we had is, can we use water on these things? if you go and you take a look at the 2016 ERG, and I haven't looked at the 2020, so forgive me, but the 2016 ERG, when I first looked it up, I said, let me go to the emergency response guide. So this book is in every emergency vehicle, police, fire, and EMS. And it's a guide toward any hazardous material. And sure enough, lithium ion batteries in there, and they give you some sort of guidelines on, hey, here's what you should do in the event there's a failure of a lithium ion battery or ammonia leak or whatever. And they give you some information. But what they do tell you in this book here is not to use water. So we were like, oh, wow, what are we going to put this out with? We wound up finding out later that water is going to be one of the best things that you can use, because we did some work here in the fire academy, and we want to know, well, if we're going to use water, is that stored electricity going to start to come back to the person that's on the nozzle spraying the water? Is there going to be electrical leakage back to that person? And Con Edison laid out, again, Con Edison really rose to the occasion and came, and they gave money to have this work done. And we found out that, you know what, you can get pretty close to these things and you won't get any electrical leakage. But the nice part is, I'm telling you now, even though we did this report and it's a nice to know, we're going to stay as far away from these as possible and use the reach of the stream if we have to make sure that we don't get near these things. But this is also good for us. And it was a good study done by them, but it showed that anytime you add anything to water, it made it more, that made that electrical leakage even more, made it more conductive. The water became more conductive, so more electricity came back to the person on the nozzle. So then we decided, all right, that we use water or no water. Well, in some cases, you may want to use water. In some cases, you may not. When you have these things on the top of a high-rise building in Manhattan, you may want to use water in that situation because that smoke is going to go somewhere. But if they're in the middle of a field, maybe one of the things that we may want to do is not use water. Maybe we will let these things burn. And right now in NFPA 855, the committee's looking at that as an option. Most times that's very difficult for a firefighter to allow things to burn, right? But as long as we know that this thing, we're not saving it, but we don't want this one that's on fire communicating to this one, we may be able to let that burn and maybe just using water to cool this down so the heat doesn't transfer over to this one. So I know some of you people are saying, wow, we can't let these things burn. But you know what? There's companies out there that they are encouraging you to just let it burn. You're not saving it. So that's still in discussions. I want to be very clear on that. But it's something that the committee is looking at as giving guidance to firefighters as a potential of just allowing these things to burn. Another thing that we also looked at is signage, right? We wanted to make sure this signage is out there for the firefighters, making sure that they had a good information, right? What type of technology? Is it lead acid? Is it lithium ion? Is it NiCad? Is it nickel metal hydride? What type of technology? What's the hazard that's involved with it? Is there an emergency phone number, and what suppression system may be there? There may be a clean agent in there. There may be a water sprinkler in there, a mist system, something. So all of that stuff should be in the signage. And that's something that for my AHJs that are on here, my code officials, this is something that you may want to consider when having signage put in at these installations that the firefighters can use. Anyway, so just make sure that not on the enclosure, and that you also have it's visible for the firefighters and on all four sides. Also, emergency response plans, they need to be site specific. Now, what we started to do, and I still do a little bit of work with the New York City Fire Department, and what we're looking at is, can we actually streamline these things and make them so they're all the same or similar to like an SDS sheet where you have certain sections, and we know that they have to hit certain sections of that particular emergency, that particular section, to make sure that they cover it when they're submitting the plans to the plans reviewer in the code, or the code officials. But they have to be site specific. So it takes some time. You know, we have to take a look at what happens when an alarm goes off. How do these things shut down? What does the BMS do? How does it work? All of that stuff should be part of that emergency response plan. And also it should be legible that the responders can understand it. So emergency response plans start to become an important item, and they need to be available at that location, maybe in a lockbox. I don't know how else you're gonna keep it there, because most of these things are unstaffed, these energy storage systems. But in New York City, they're putting them in a lockbox where the firefighters will have access to them in those lockboxes. If you take a look at this picture right here, I was in California at a meeting, and I get a picture of this right here. For those who don't know, this is an actual module of a battery. They threw it in the back of a sanitation truck. When the blade came down in the back of the sanitation truck, it squished it, and sure enough, the energy was still there. It had a little bang, and it went on fire. So we started to say, you know what? What happens after the fire? What do we do with these things? We got to make sure these things are taken out properly. They need to be decommissioned. Someone needs to be responsible, because we still have that stored and stranded energy there. And if these things were on fire, the safeties on these things to make sure they don't go on fire has now been compromised as a result of the fire. So, and there's still that stranded energy there, even though they went on fire. So something also that you should be considering is that decommissioning, making sure these things come out, that they actually take it out of there when they are damaged or they fail. Now, we were talking earlier, and we were mentioning about APS, or Arizona Public Service. There was an incident that took place, and this is really where it woke up the industry that they really need to start to look at training the firefighters. So I figured I would hit this head on, right? Again, not trying to scare you, only trying to tell you that there was a lot of lessons learned in this particular incident. And there was some bad things that came out of it because firefighters got hurt, but there were some good things that came out of it because the code started to address the things that happened there, and which is good for us. This particular incident was, when it first was put in, it was put in an old code that really didn't address what we have here. It didn't really address what was going on inside here, but just some of the ideas of some of the stuff that was in here, as far as it was an LG Chem battery and lithium ion and type of nickel, magnesium, cobalt, not stuff that you really don't need to know, but more information. It did have smoke detectors. It did not have water inside there. It wound up having what they call a clean agent, which basically the chemical reaction to stop the fire, or it knocks out oxygen. It could be either or. There was no explosion control. There was no exhaust or anything of that sort. The BMS data was not available for the fire department. So none of that stuff was available at that particular time. So here's the event and what took place. So there was a 911 call for smoke in the area. They were updated en route that the people from APS called, and they did mention that it was a battery storage. They told them it was lithium ion, a lithium ion battery on the inside there. And the firefighters said, okay, so they showed up to the scene. They did see the smoke. They were met on the scene by the operation and maintenance people, and they wanted to go inside to do a diagnostic. But the fire department saw smoke pushing out of this particular area here and this particular area here. Upon arrival, you could see this is a stretched line, and they said, you know what? Let's hold off a second. We'd call in our hazmat. So they wound up calling up in their hazmat, which was Peoria Fire. Peoria came in, and they did a couple of laps around the actual structure itself. And for about 2 hours, 2.5 hours, they actually did a size up. Couldn't get anything off their thermal imaging camera. So they said, okay, what do we have to do next? Maybe we need to start thinking about going on the inside. So they opened up a door with this white smoke came out of the door. It hugged the ground. The smoke was consistent. Responders actually did not go on the inside of it, so, which was pretty good, right? Normally guys would just jump right in there. Okay, give me the hose line, but they didn't. They had a tremendous amount of respect, and they waited on the outside, but they had no flaming going on. All they did was see smoke. And then sure enough, an explosion took place. That explosion here, the blast came through that door and sent the firefighter 75 feet back. This is where he landed. This is his helmet here. You can see all of these things were blown off. This is a cover panel for the HVAC systems here. And this is the door that came here. 2 firefighters. One was thrown into the fence. The other one went underneath the fence and landed here. And they were in tough shape. They've made I think they made a full recovery, but they're up and walking again. I do know that. I don't know how bad their injuries are to this day, but I did meet with them, and they were still in, they still had some limping around. So I don't know if they're completely healed, but they're okay as far as they can get around. So so yeah, there was that explosion that took place. So the explosion actually pushed one of those firefighters right underneath the ground. This is his high pressure hose from his SCBA. For those who don't know, an SCBA is the self-contained breathing apparatus. It's basically air on the back of the firefighter that they can breathe when they go into a fire. But this was ripped off. Very difficult to do. That's on pretty sturdy onto a SCBA tank. This was the rear of it. The explosion blew off this particular doorway here. It kind of mangled the fence in there. This is just a back view on how other things were blown out. Again, this was the door that was blown out. It came crashing over here. So they said no one died on it, which was good. But this was an incident that really had us all looking. And there was a lot of reports. There were 2 reports done, and I think Mo has them. I'm not sure. If not, they were done by DNVGL and also Underwriters Laboratory. And I think they're pretty good reports. If you're writing that down, you should do a search on that and look at what they said. I thought they were very fair reports on what took place. As you can see, we have an actual bow in this building. So that was a pretty good deflagration, right? That was a pretty good explosion that took place because the pressure actually pushed out against there. Again, I tell you this because not to get you nervous about it, just to let you know that the codes now address this. In New York City, we thought this could happen, and we addressed it. And I don't want to get into the different things that we did because Mo's going to speak more about that. But there are engineering controls that now start to manage that explosion, and hopefully we won't see any of this ever again. This is again why we don't want the firefighters to go too close to these things or go inside of them. Definitely do not go inside of them. There's no reason to go inside of these things. And this is my last slide here. What I have here is, you can see this here. This is 7 containers. This was one of our first installations in New York. I'm sure you're all saying, how the heck did they put that in there? Well, we looked at a lot of engineering controls. We felt we over-engineered this thing. Maybe there's a couple of things that we would like to have done over, but overall, these things are up and running in New York City. This is a public assembly area here. This is a group of stores here. This is an actual school that's right here. This is some private dwellings across the street here. This is a train line going here. We have done numerous drills with the local fire department. They know exactly what to do. There is a fire department connection where the fire department is basically just going to flood these things if they go on fire. And so these things here, for those who know anything about it, are probably questioning it. But again, this was the first one put into New York City. We've gotten even better than what we thought here. And at that particular time, we thought we were over-engineering them. But we did a pretty good job on getting these things in. We were being pressured to get them in. It took almost 4.5 years before they actually allowed these things to go in from the time we started investigating them. But they're up and running now. There's been no problems with them. We've done a lot of work with the local fire companies to make sure they're on board. The school's notified about it. These people are notified about it. There's alarms every place, all over the place. Things shut down if there is a problem. So that in itself should let you know that, New York City has taken some really strict stances on getting these things in there, and they put them into a location like that. So I think we're going to open up the questions, right, Maz? This is where we open questions right now?
Yes. That was It was a really great presentation, Paul, and I want to get to, we have a couple questions here, but I want to get back to this thing about protecting fireworkers, because you were actually mentioned to us in another discussion about drones being used as something that could potentially help investigate the potential for fires and protect firefighters from being less exposed to the situation. Would you recommend that type of equipment that should be considered?
Yeah. That discussion has just come up, man. Maz, is this idea of utilizing drones. New York City has now a robust drone program that they use, and now why not use it for this renewable energy, especially when you have these large solar fields where there are 2 acres long or whatever. We don't really want firefighters going in there. Right? What are we gonna do? So what's the best way? Are you gonna put up a helicopter and cost all that money to get these helicopters to get over there, and they may not be available? And I think drones are going to be utilized much more than the helicopters, will be able to handle all the work. But I think that drones definitely going to have a place. I just reached out to my colleague in the FDNY, Captain Leo, who's in charge of the drone program, and I was asking him some specific questions about this, because I'm in the process of doing some work with Office of Fire Prevention and Control, and this is something that we're going to discuss and see if we can utilize that. Maybe this could be something that could be used for firefighters to enhance their capabilities of looking at things from a bird's eye view.
Oh, that's great. Yeah, technology is really advancing, so let's use it. And I had a question here. Somebody needed to know where was the school that you were just referring to?
Uh-oh.
Uh-oh.
No, I don't know the name of the school. It's a primary school. Again, they have the Department of Education was informed about all of this. They are aware that it went in there. They do drills on it. In the event that there was any type of emergency, the fire department in that area, the local houses know to divert the children the other way. But again, hoping that nothing takes place. But I don't know the actual number of the school, because they have the PS 12, PS 18. I don't know what it is. So I apologize for that.
No worries. This person was just interested and thought your presentation was great. So they just wanted to know whereabouts, the borough or the street or wherever the
Oh,
school
it's in
is.
Queens. I can tell you it's in Queens.
Queens?
Yep.
Cool. Okay. And so I have another question here. Are most of the new units cabinet-based versus walk-ins?
Yeah, great question. Yeah, and obviously that person's been reading the code, and there is a difference between a cabinet base and walk-in. Yeah, the ones that I showed there in Queens, they were walk-in containers. But everyone is starting to go toward cabinets, even though they look like walk-in containers. By the definition of cabinets, they're cabinets. If it can access those batteries from the exterior of the enclosure itself, it's considered a cabinet. So no one can actually walk in the inside here. So yeah, so there is that person's read their code. Good for them.
Yeah, good for them. I have another quick question here. We have maybe time for one other question after this. To what extent are the considerations you recommend, suppression, fire response procedures, decommissioning, incorporated into the New York State Building and Fire Code? Great presentation, by the way.
So believe it or not, the New York State Fire Code and the Building Code, but more the Fire Code, has really addressed this in Chapter 12. They put out a 2020 version, and what they did is they were the first in the nation to adopt a modified version of the International Fire Code 2021 ESS, right? Chapter 12 of 2021 of the ESS. And what that did is it brought in a lot of aspects that made it safer for the fire service with large scale testing, which is really, really big, which I think Mohammed is going to get into that. That's a big thing for those who don't know, large scale testing, but it really says basically, hey, if you're going to put this much energy, prove that it's safe. So they make them do destructive testing. And if you can prove that you're safe, then it gives you a lot of leeway to do other things. So it throws it onto the owners of the system to say, prove your system is safe and that you can put this in where you want to put it in. And it gives more options on where they can go in. So there's a balance there, right? There's a balance between proving it safe and giving more options to the people to put them in as long as they can prove it safe.
Well, that's what everyone wants to know, and including the first responders and people living in these communities. So, well, this is a great presentation. Thank you so much, Paul. I want to move on. I think we've kind of covered, oh wait, I have one quick question here. I want to see if we can get this in. How are appropriate separation distances determined with respect to other uses? And that'll be it for our questions.
I think they mean other separation distances.
Determined with respect to other uses?
Other uses, other buildings. Oh, okay, yeah. So the code says 10 feet. That's a big number, right? 10 feet. So what I would recommend, this is Paul Rogers, this is not the code, is if you're concerned about any type of heat going close to another building, you can have them do a heat flux analysis to make sure that it will not have any effect on the buildings that are adjacent to it. And maybe have some sort of PE sign off on that a heat flux analysis was done and there would be no problems. Again, proving, have them, sometimes you got to hold the people to the, they're putting these things in there. If you feel that you're uncomfortable with them too close to a building, then have them do that extra work to make you feel comfortable that you are giving them permission to put it in. And I'm sure that's a code official asking, which is a great question. And if they don't feel comfortable, then they have to feel comfortable in order for them to permit it. And I commend them for doing that. But ask. And I think most reputable people will do that. Most of them will do that. Like, yeah, we'll put that in there, which is good. It's a good thing.
All right, thanks again, Paul. Everyone's commenting about what a great presentation you had given us. It's so informative and so easy to follow. Okay, so our next presenter, I had a question about whether this was being recorded, and yes, it is. So we're going to have a recording of this presentation, and it'll be on the USE's website. So those of you who really want to pay attention to this in more ways, you have an opportunity. So our next presenter is Mohammed Kassamali, and he is an energy storage safety practice lead at DNVGL. He has 4 years of experience in the energy industry at DNVGL, focused for 2 years on behind the meter and utility scale energy storage technical due diligence. He provides technical review of various battery energy storage products to manufacturers and developers, assessing systems, safety, and performance. Mr. Kassamali is a battery energy storage safety expert that has conducted numerous safety analysis reviews for high-profile energy storage projects, and with a great understanding of safety standards, codes, and best practices. Furthermore, he has extensive experience in UL 9540A test result, explosion risk, and gas dispersion analysis. Additionally, Mr. Kassamali has performed microgrid techno-economic assessments and microgrid modeling. He earned his BS in energy engineering from Pennsylvania State University. Thank you, and we welcome you, Mohammed, to our wonderful educational session. And I really hope that everyone gets a lot out of this. So we appreciate your time. Thanks.
Thank you for the introduction, Maz. And Paul, great presentation as well. A lot of what I'll be presenting today is going to be covering similar aspects to what Paul has presented, and you'll see some synergies across the board. So a little bit about what DNVGL does on this slide is we're an independent engineering consulting firm that looks at the life cycle of energy storage. So we're here in the beginning, understanding feasibility, whether this makes sense from a dollars aspect, so economical feasibility, but then also feasibility with respect to safety and managing your risks. As you see in the second column here, testing. So that could be performance testing to make sure your batteries aren't degrading quicker than they should. Also destructive testing or UL 9540A testing at the cell level. We also are part of the development and engineering process. So, following up on the previous aspects of feasibility and testing, we're leveraging that experience and knowledge to do due diligence for financial institutions, insurers, developers, integrators, or even manufacturers in the space of energy storage. And then the last two is, more so on the back end of the life cycles in construction and operation of these systems. We want to make sure we install safely and operate safely, as well as maintaining the systems where they should be. Eva, if you can move on to the next slide. Thank you. So here's a handful of reports that we've conducted alongside NYSERDA, the Ravenswood example with Con Edison, FDNY, et cetera, that was covered by Paul earlier. The first on the left is the considerations for ESS fire safety, which was done with Con Ed, and that was conducted in 2017. And it was truly groundbreaking in terms of, breaking some investigational analysis into what really gets these batteries ticking and really what gets them to, kind of calm down once you get them started. The quantitative risk analysis supports that as well. It was a subsequent report that kind of goes over at a high level all the risks associated with the energy storage system, as well as its components, to better understand how to design a system and lay out a system. And then lastly is a technical guidance note on behind the meter storage systems. So oftentimes you'll see front of the meter installations and behind the meter solutions kind of resembling themselves in their nature. All they're really doing is different functions, but for the most part, the similarities are there in the design. If we can move on to the next slide. So on this slide, I'm just going to be talking to you about how normal batteries are on a day-to-day for all of us. Your car operates on a battery. Your phone operates on a lithium-ion battery. Whether it's a Samsung or an iPhone, it's going to have a lithium-ion battery. Your pacemaker may have a battery. Your smoke detectors in your house, or your carbon monoxide detectors, I should say, will also have batteries. And then similarly, so energy storage it's a battery in itself. While there's different compliance and quality assurance associated with each of these batteries, the closer these batteries are to interactions with humans, the increased level of safety is required from these governing agencies or codes and standards. So, similar to what we experienced with phones not too long ago, with Samsung having an issue with their phones, those quickly were recalled, and you see that those phones aren't sold until that those updates are made and design changes are made. Similarly, so with the story that Paul told you with APS, batteries at a certain point, that guidance wasn't there yet. But as the industry has developed since, 2 to 4 years ago, it's come a long way in understanding what bridges those gaps to normalizing energy storage technology and making it safe. And that way it's not necessarily an endangerment to any asset loss or life loss. If we can move on to the next slide here. So this is just going to be a little bit of energy storage 101. Of course, I talk about a plethora of batteries in the past slide. And these batteries are all different types of batteries. You have lead acid, lithium ion has variations such as lithium iron phosphate, or even lithium nickel manganese cobalt. Those are the two often variations that you'll see within lithium ion. Within this diagram, you'll also see electrical storage as well as mechanical, but almost 95% of the installations across the United States fall within the electrical chemical realm. And then even beyond that, 90% of those installations are falling within the lithium ion realm. So the focus here today is predominantly on lithium ion technology, but nonetheless, there is guidance, and safety should still be considered when dealing with other energy storage systems. We can move on to the next slide, please. Eva, can you move on to the next slide? Thank you. Oh, one more back. Yep, there you are. So batteries come in all shapes and forms. The cylindrical one on the far left is, something that you're probably more familiar with, that goes on behind your television remote. It goes in literally everything that you probably have to apply batteries to in a household appliance. But those batteries are also used for energy storage applications as well. You go all the way to cylindrical and the pouch and the prismatic, and the scale on the bottom here where it says 1 AH, that stands for an amp hour, and it's a unit of energy. Goes all the way to 100 amp hours here on the scale. This just shows how different designs may retain larger energy capacities compared to the others. So the pouch and the prismatic designs here on the far right are more representative of what you'd see in an energy storage application. So the prismatic is it's broken down a little bit further here. As you can see, it's not just simply a cathode or an anode within the electrical chemistry going on here. There's other aspects to this cell. You have a pressure vent, you have a can case, there's a top plate, and it's all, packed into the small little device that, can hold a relatively large amount of energy, which is certainly impressive. But once again, as Paul alluded to, this energy could potentially lead to some level of risk that we should consider. It is important to note that lithium-ion batteries do not contain lithium metal. While they are such things as lithium metal batteries, they're not a commonplace, and the safety around those type of solutions has not yet been validated like it has been for lithium-ion. It's important to note not to mix the two up. If we can move on to the next slide, that'd be great. So continuing on with Energy Storage 101 here, we have, this is an overall schematic of, what would be involved in an energy storage system. Of course, this schematic on the right might be just difficult to follow, but I'm just going to cover it at a high level, where, you have your batteries. Your battery cells, your modules, your racks. And an analogy I like to use when describing those, for those of you who don't know what that looks like, my subsequent slides will show you a little bit what that looks like. But just to picture it, imagine the battery cells being a pair of shoes, and the battery module being a shoe box, and then the battery rack being a series of shoe boxes on the shoe rack. And then the container would be that actual shoe store. So that would be the enclosure for all of the assets, which would be the shoes in this case. In the battery energy storage case, the asset would be the batteries within the container. Beyond that, there's the inverter. So the inverter is responsible for power conversion from AC to DC, or even DC to DC, between grid, transformers, energy storage system. We also have communication and monitoring and controls equipment. Communication, monitoring, and controls, which we'll get into a little bit later, is crucial to the safety and management of an energy storage system. Paul alluded to in his slides where, in the past, data maybe was not collected or monitored. So, to understand really what was going on in failure modes, where it was tough to really, do a root cause analysis or really pinpoint what went wrong. Whereas now, controls and monitoring is the utmost importance, in the sense that the levels for that within the standards that are required of these systems, it makes sure that you have systems that are able to effectively monitor crucial parameters such as temperature, voltage, overcurrent, in some instances, they can even predict hazards such as thermal runaways by rise in temperatures or even venting of off gases. Nonetheless, these technologies are improving and getting more creative as these codes and standards are developed. As we have concrete guidance on what's needed in these systems, solutions are coming out very fast. So if we can move on to the next slide, you might have to click through this one a little bit. So this is exactly what I was describing with respect to the battery storage container. It involves a series of different equipment. So you have your battery cells, which are housed in these black locker looking things. In the back, you have your thermal management, which in some cases may be an HVAC unit or multiple HVAC units, which provides environmental conditioning for the whole entire container as to maintain batteries in their operating stages as prescribed by their manufacturers. In some cases, there are batteries that are liquid cooled with like a ethylene glycol water mix. Those are becoming more popular as they provide a thermal barrier as well as more effective and localized cooling than HVAC systems do. So that is certainly something that's being seen in the market and is an interesting point when it comes to safety. As thermal management is a crucial part of safety. On the far left here, you have your controls and disconnects. So these controls allow the system to operate under ideal and normal conditions as prescribed by the manufacturer. But when they're not, these control systems and monitoring systems are able to detect that and cause a disconnect as to isolate the system to make sure that there's no cascading failure, so to speak, and to avoid a potential consequence. And then there's other safety systems within the that may be involved in the system, and we'll get to those a little bit later on in the slide deck. But here, what we're pointing at is likely a clean agent solution. The clean agent solution is primarily for some incipient type of fire in an instance where you want to put out that fire, smother it, and then if there is damage or potential continued heating, that's where water would come into play, as it's the most effective coolant of these batteries and preventing that reignition of these batteries. So if we can go to the next slide. I would like to define the hazard that is most associated with lithium-ion batteries. Paul did a great job in covering the gambit of risks and hazards that are associated with energy storage systems, which come into play with fires, electrical shock, off-gassing, even explosions. But here I'm going to assess, a failure mode in what is called thermal runaway. Thermal runaway is a phenomenon within battery energy storage systems, specifically lithium-ion batteries, which is an uncontrolled heating within the cell, which may be caused from, an overcharge of current, voltage. It could even be from external initiators of temperature. So if something next to it is hot, or if there's a fire adjacent to it, it could cause thermal runaway. This thermal runaway leads to a series of potential hazards that we have to keep in mind when considering our design. So if you just click twice, those should be some diagrams that come up. Yeah, thank you. So here, I'm just going to walk you through the whole process of, what's happening during thermal runaway and maybe where we could prevent it. So this preventative region where we're at right now, this is where, you could have an abuse factor. And an abuse factor is something that, is making the system operate beyond its normal operating conditions or beyond what it's recommended to operate at. So this could be, high temperatures, as previously mentioned. It could be the failure of the grid. It could be the failure of other equipment within the energy storage system. It could also be an impact to the battery. So there is a vehicular accident somehow or where there's a forklift that hits a battery that could cause a cascading thermal runaway. So this is at a point where you can prevent it in terms of disconnecting and isolating the system, and then responding with active a response, by notifying facility personnel as well as emergency responders if the escalation is occurring. And if you just click onto the next graphic, that would be great, Eva. Ooh, you just go back one more. Thank you. So here we have the onset of thermal runaway in this reddish area where essentially coming into a play of smoke, off gas. So off gas will include some flammable and explosive gases, which in lithium ion technology often includes hydrogen, some hydrocarbons such as methane or propane. Can you go back to that slide? Thank you.
Sorry about that, Mohammed.
No worries. It could be methane. It could be a multitude of hydrocarbons, but also carbon monoxide is often found in this off gas. So as that's building up, it potentially builds up a flammable or explosive environment that could lead to a fire and explosion. And that's what's happening here on these second order impacts where high heat is causing cascading failure, fires, and or explosions. So that's really what we're defining here as the hazard and what we're going to be addressing with the mitigations. So if we can proceed in the next slide. So here's what I'm kind of just going to quickly walk through is, in managing these hazards, we have to assess risk, at a high level and understand the consequences and the threats that associate with the system. And then what we have as these preventative barriers to prevent, this hazard event from happening. So in the case of thermal runaway, do we have protections in place? In the case of fire, do we have protections in place such as clean agent suppression, water suppression, et cetera? So that's what we want to build out is more barriers to these threatways and consequence pathways to allow layers of protection within the system to prevent a larger, more catastrophic event. If we can move on to the next slide. I think sorry about that. I just mixed up my slides. Energy storage risk in perspective here, just putting all of this in the purview of other industries or even other technologies is, working or living near an energy storage system is less risky than driving your car 10 hours a week. And that's just by overall numbers of fatalities and risks and the severity of that risk. Another example of this is, working or living near an energy storage system is safer than working in other industries such as agriculture, construction, or mining. And once again, that's a function of the data that's been collected to date. These may over time prove to be safer in the terms of overall, injuries, lives lost, et cetera. As mentioned previously by Paul, we've experienced injuries in the United States as a result of energy storage systems. Luckily, we have not experienced a death in the EPS instance. We'd like to keep it that way. And a lot of that, comes into play with, the development of new standards, codes, and requirements. So with that, we can move on to the next slide. You can move past this slide. We kind of just covered that. So when I reference these standards, codes, and requirements, I'm going to go through each one of these and what they mean to the industry and you as code officials. So NFPA 85 is not a legally binding document, but currently standing, it's certainly the most comprehensive or robust set of best practices associated with energy storage systems. So NFPA 85, it really, put energy storage guidance all in one place and allowed for, other codes and standards to kind of reference it and build off of it. So off of NFPA 55, you will see that, IFC 2021, the fire code within New York City, the California fire code has adoptions of NFPA 55 to certain degrees. There might be exceptions or variations in certain instances, but for the most part, they're very well aligned. So 55 was, the culmination of a lot of these codes being improved and fitting the needs of energy storage safety. Within NFPA 55, it prescribes NFPA 68 and NFPA 69 as mechanisms of examining, calculating, and then also designing explosion protections, which NFPA 55 calls out explosion protections as being required for all lithium ion technology. That may vary by code. In New York City, that's accounted for, explosion protections, and certainly should be. So moving on, in the IFC 2018, which is the International Fire Code, which I'm sure many of you are familiar with, is widely adopted and is often, served as the baseline for statewide or countywide codes. Here we have a gamut of UL standards. So that's the underwriter's laboratory that Paul had mentioned earlier as part of his investigation experience. So UL has provided a series of certifications, testings, and standards that you could adhere to ensure that your energy storage system is safe, specifically a lithium ion energy storage system. Starting off at the cell level, UL 1642 is a series of tests and requirements that really adhere to making sure that the cell can tolerate certain abuse conditions such as overtemperature, overcurrent, undercurrent, et cetera, and so on. So the next one is UL 1973, which is covering that module or that more so system level of multiple battery cells. And it's an added degree of testing and scrutiny as there's more components involved in this system. UL 1741 is dealing with an energy storage component, not specifically a battery, but an inverter. And that's a listing which are often can be found on UL's website or even on the manufacturer's specification sheets, I should say, which will provide this insight to you on whether or not these products are listed to these certifications. Now, these last two are more nuanced certifications or testing protocols. And so UL 9540 is a field evaluation or certification process for your entire system, which involves your inverter, it involves your battery and other system components. And essentially what UL is trying to do here is assess the interoperability of those systems to make sure that they're firing on all cylinders, communications are happening, power conversion is happening, proper discharge and charging is occurring. All of that is assessed in 9540, but it's also assessing key safety features such as thermal management, venting of off gases, UL 9548 testing, which I'm going to get into right now. So UL 9548 testing it's currently in its 4th edition, and it's currently been a learning process in how to accurately and properly test these battery cells. But this 4th edition of UL 9548, which came out last year, has gone a great length to prove, whether or not your battery cell is a safe design. So this test is done at the cell level, it's done at the module level, and then it's also done at the unit and installation level. The unit is defined as either the battery rack, or it could be defined as like an enclosure, such as a cabinet style type of energy storage system. So the UL 9548 test is not a pass or fail. So it's not like you don't get a certification. There's no such thing as passing it. But what it really serves as is a data collection and an observation exercise that allows energy storage manufacturers, integrators, and developers better design their systems to be safe by using the inputs of understanding the hazards of thermal runaway and the off gases or the fire that could be that can emanate from a thermal runaway event. That could take us to our next slide, Eva. So managing the hazard and protecting against thermal runaway, which is the hazard we defined earlier. So this can be done in many ways. So this starts off as a construction assessment, right? You want to understand that these components are going to be fit for purpose. Do they have the certifications that we just mentioned, UL 1973, UL 1741, et cetera? But also do the smaller components such as, nuts and bolts, are they fitted properly for the solution? Are they properly suited for outdoor use, et cetera? And the next part is this performance area where we're talking about different types of testing prior to even installation or even design, and understanding what batteries are performing, and if they aren't performing, what's causing them to not perform. So there's electrical tests where, you could do a plethora of different testing of testing over voltages, under voltages, fault currents, discharges, thermal management system failure, voltage measurements. Then there can also be mechanical tests such as vibration, shock, crush, static force, impact, wall mount, mold stress. And then there's also environmental tests such as thermal, moisture, salt fog, external fire exposure, and then tolerance to the internal cell for failure of these cascading protections. There's also manufacturing assessments at the manufacturing level. So, they would adhere to ISO standards that are with respect to manufacturing lines. So that would be 9001 in terms of their manufacturing. And then they'd also have some management protocols that they would adhere to on ISO as well. With that being said, we can move on to the next slide. So in defining another hazard here, what does a battery fire look like? So as Paul alluded to, ESRG and DNV has conducted a fair amount of large-scale fire testing, whether they be a bespoke test or UL 9548 test. We have a fair understanding of what happens when there's a fire and what occurs. So here we're looking at fires with no protections in place to understand a worst-case scenario. These are, purposely put on fire to understand what happens to them when they're on fire. This is a battery module on the left, and then on the right you have a container. The number one takeaway here is batteries do not create unique or unknowable risks and can be managed through firefighting best practices. And by that, I mean, these fires are not that different than a plastics fire. There is a risk of, deflagration, but the fire in itself can be treated in a similar fashion as other fires are treated, in the sense that copious amounts of water should be used. There will be in most systems that are installed across the spectrum some type of first layer or first defense of fire suppression, and that may be a StatX aerosol, it might be a clean agent, it could be some other type of suppression system as well. With that, we can move on to the next slide. So in managing the fire, there's different risk mitigations that we can account for through design. So you can monitor within the container and using sensors. So that would be like heat sensors, smoke detectors, things of that nature that would allow you to give you some indication that a fire could be imminent. And then beyond that, as I just previously mentioned, internal fire suppression systems that can limit, that initial propagation of fire as to protect the other batteries within the container or enclosure, and thus, protect a greater, protect from a greater catastrophe from happening. There's also built-in exhaust and ventilation systems, which can, prior to a fire happening and upon detection of a gaseous volume, whether it be hydrogen or carbon monoxide, some systems are capable of triggering the HVAC system or other exhaust ventilation to move those flammable clouds out of the container and only introduce fresh air to the system, as to avoid for an environment that's conducive to a fire or an explosion. So with respect to emergency response when it comes to fire, Paul covered it very well. There's certain different approaches here. Water is certainly, the most effective suppressant. As previously mentioned, there's other non-water-based suppressants that may be useful to prevent and minimize the spread. But certainly water is the most useful in cooling the battery down and in preventing that reignition. A containerized system may burn for several hours depending on the suppression technique. I know in the most recent Liverpool incident where the batteries are, I believe they were installed in 2016, and prior to any of these codes being installed, Liverpool and the UK in general were way behind even the United States when it came to best practices associated with energy storage systems. So it didn't really have any protections built into the system. So the firefighters happened to be fighting that fire for hours. That might vary depending on the situation. In that case, it seems like the lack of protection prolonged the emergency response, but that investigation is still being conducted. As Paul alluded to, a let it burn approach may be a reasonable defense tactic, and that may be in a highly remote area. If you have an energy storage system in the desert and there's no direct endangerment of life, it may be the firefighter's best interest to take a defensive approach and let that burn, as the asset can be considered a loss, and life safety is of course the most important. If there was life safety in danger, maybe that decision would be a bit different. We can move on to the next slide. So defining another hazard in the explosion is an assessment that you can do by leveraging your UL 9540A data. So the UL 9540A data provides you data on gas composition, flammability limits of that gas composition, and it also gives you the total volume of that gas. Beyond that, it also accounts for overpressures. It also accounts for burn velocities, and these are all aspects that are crucial to understand an explosion. So what DNVGL has been able to do for its clients, and similarly so with fires, we've been able to model these scenarios leveraging the UL 9540A data. So this is a model that we've conducted where we're trying to measure the overpressures as a result of an explosion. So one, you want to understand the gas dispersion within the given enclosure, as within a closed space, as more gas is being released, the potential for an explosion or flammable environment goes up and down, in the sense that you're going from a place of increasing volume of no flammable or explosive gas into a place where it's called the lower flammability limit. And then you also reach a point where it's the upper flammability limit, where you're oxygen depleted, and the introduction of oxygen could lead to an explosive environment. So what we're looking at here is the effects of that and the potential for that. That way we can provide our clients who are integrators or developers or even manufacturers insight into designing better, or designing explosion protections such as a deflag panel or exhaust ventilation to move out these gases to prevent an explosion. But such analyses could also be utilized by code officials or authorities having jurisdiction to better understand what radial effect these overpressures may have. And then similarly so, plume analyses can also show what the toxic or the heat radiation effects are beyond the enclosure. And that will, maybe allow us to better define setback zones, exclusion zones, but also allows us to understand what the effect is on adjacent exposures, such as, the school building near that other site that Paul showed. Maybe, if there is a fire, we would want to evacuate that given area for 2-3 blocks. Maybe if it's understood that, maybe the plume is only going to travel 25 feet, maybe then we don't have to evacuate that much. Maybe the plume is not going to be as toxic as we thought it would be. And these type of analyses would show you that. But once again, you have to leverage the UL 9540A data to understand that, which DNVGL does. So in our studies of understanding explosions, the number one takeaway that we as DNV have found is the potential for explosions and related mitigation design will be determined by the test, as the test being UL 9540A, and basic standoff procedures can keep you safe. And those standoff procedures will likely be derived from these analyses. If we can move on to the next slide. So as previously mentioned, we can manage this explosion, one with built-in exhaust and ventilation, similar to what I was saying about for the fire hazard. We can remove these flammable or explosive gases prior to their buildup being a concern, and that's triggered by a gas detection system that will tell the HVAC system, get this gaseous volume out of here and bring in new air. And that's what that function is. And then there's also deflagration panels, which serve as a mitigation tool or an explosion control tool, which they're common in other places in the industry. You'll see them in oil and gas or in hazardous materials, buildings. But the deflag panel is a design weak point on an enclosure where a certain part of the roof of a container may fly off at an easier rate than any other part of the other parts of the container, as to control the direction of the explosion. So often, and actually almost always, you'll see those deflag panels being on top of the container as to not radially cause debris to fly. So emergency response here is emergency services should not enter the container when a battery failure may be occurring. More and more you see the systems are less occupiable and not walk-in containers, so that's less so a case. But for the instances where there is a walk-in container, no one should be in that container. Procedures will be in place for any man-down situation, but also handheld detection tools, the typical 4-gas monitors would be leveraged to, detect gases there to better understand the effects of this downward gaseous volume. With that, we can move on to the next slide. So this is just a depiction of what smoke looks like from a battery fire. So this is a fire coming from the container here, or I should say smoke coming from the containers. These are modules that are with no protections in place. So as previously mentioned, the toxicity associated with these fires are very similar to plastic fires. And then typical SCBA, which is a breathing apparatus, will protect first responders during operations who are trying to approach the given enclosure. We can move on to the next slide. So managing toxicity as a hazard, and once again, we can manage that through exhaust ventilation and moving those gaseous volumes and explosive volumes of gas out as to avoid for a fire even occurring. But also site design will be based on large scale fire tests. So, you could identify, as I previously mentioned in those plume analyses, and which is shown in this graph here, what effect, so the red here is showing the downward effect of as a subject of certain wind patterns of the toxic plume that travels downwind. And in this instance, the container's on the far left and it's traveling as far as 25, 35 feet, depending on weather conditions. And that is crucial for people to understand to make sure that they're not exposed to toxic environments for too long. Oftentimes these exposures that will affect you occur for lengthy periods of time of anywhere from 1 to 8 hours. Oftentimes when there's an emergency, people are not in that vicinity for that amount of time. They're often escorted out or evacuated out in a much quicker timeline. So avoiding those toxic plumes are certainly crucial to protecting the first responders, as well as any facility personnel, as well as any bystanders. So emergency response to such toxic effects, for such toxic effects will be the self-contained breathing apparatus, as previously mentioned, the 4 gas sensors, as previously mentioned, but also including a plan for this in the emergency response plan that, may be located on site in a lockbox, as Paul alluded to earlier. Also, and lastly to this point is water runoff. So if water is applied to these batteries, there's a toxic effect of hydrogen fluoride that's potential water runoff from this. It has not been shown to rise to regulated levels, so levels that that would cause a regulatory concern, and can be tested to confirm in the stormwater management plans that may be part of the system documentation. We can move on to the next slide. So this is our last hazard that we're going to be trying to manage here is tactics and tools for electrical hazards. Once again, I'm going to state that monitoring controls are certainly the most crucial part of understanding what's going on in the energy storage system, and that is rightfully so connected to electrical hazards and the potential for that hazard to cascade. So monitoring that, looking at current, voltage, et cetera, is certainly something that we want to understand at all times. And if there is any out of balance or, out of range parameters, that should be alerted and shutdowns should occur. So the emergency stop, as Paul ended his slide on, or one of his last slides, where it's a crucial part in making sure that the system is isolated and people are able to safely remove themselves from the situation, but then also it allows for the protections to go in place to prevent any cascading failures. And if you can move on to the next slide. The key takeaways that we've taken from my experience in New York and working through these codes and standards is utility scale energy storage technology has successfully and safely been implemented all over the world. Of course, there's a few instances where we have seen failures. Oftentimes are linked to a common denominator, and that common denominator is either poor manufacturing or poor design. But that was in a time of less codification and less nuance to this industry. The nuance of this industry, as you know, funding comes through, as notoriety comes through, and the need for electric energy storage comes through, has only heightened the bar for safety, and we hope to keep up with that trajectory of maintaining safety alongside the growth of energy storage systems across the United States and specifically in New York. And then lastly, the risks associated with energy storage systems are certainly known. They can be mitigated and they can certainly be monitored. And we can learn from every failure that's previously occurred. And that's what we've been doing to make sure we apply best practices going forward. And with that, I think I will conclude my slide today and open the floor for any questions if there is time for that. I appreciate the time.
Wow, Mohammed, that was amazing. And you got through so much, and it's a lot of information here. I'm so glad we recorded this. We're running a little late on time, but I do want to get to some of the questions. We have a couple really good questions, and then we'll end this in like 5 minutes. So it's 7:33, so we should be able to get everybody off here soon. But I do want to ask this question. If batteries are part of a larger solar array, how much risk would the fires pose to the solar panels? Like, what should be the safe distance from the batteries to the solar panels?
That's a good question. And oftentimes we do see solar plus storage coupled together, and oftentimes in large facilities where it's acres and acres, and you'll see like solar arrays that are just tied to one energy storage container, and then another solar array is tied to another energy storage container. And in that, what we see is, adequate spacing, such as, 10 feet, 5 feet, depending on, what results you see from your UL 9540A data or other tests that you perform, is usually a safe distance. Oftentimes a fire won't jump that distance, especially if, that container is effectively employing its suppression techniques, whether it be clean agent suppression or water suppression. So we're trying to keep that a contained event as to not catch on to any of those solar arrays as well. And that's definitely taken as a consideration.
Great, thank you so much. And quick question from a community stakeholder perspective, is there concern around contaminating the water, soil in the event of an ESS accident?
So in certain instances, yes. And I think, when I was alluding to that water runoff, there is certainly HF that should be accounted for. And certain guidance that I think ESRG and DNVGL would agree on is, certain barriers such as PIG or, covering storm drains when you're, responding to such events. But that type of information has to be provided to first responders ahead of time in emergency response guidance. And it also should be included in emergency operations guidance. So yes, there is a concern for that, but there is mitigants to that to avoid for any future issues. But even prior to all of this, permitting will also take place. So specifically in New York, there's a whole gambit of permitting requirements that will come into play, and certainly environmental protection will come into play when we're assessing that.
Thank you so much. And one final question, and then we'll kind of end this session. So should there be a soffit around the roof line so that the Arizona fire, for example, could have been prevented, since pressure would have not been built up?
So yeah, in hindsight, yeah, that probably would have been a mitigation that could be employed. And I think from what I'm understanding, you understand exactly what happened in that scenario. No, that system hit the UFL, which is that upper flammability limit. And then the introduction of oxygen when the first responders opened the door allowed for that explosive environment. So, that was that pressure relief. And you're saying over there, if there was a mitigation in place to relieve of that, buildup of gases, then it certainly could have allowed for a less intense explosion. And that's why we get to that exhaust ventilation. It's a more effective way of just getting that that flammable volume out of that environment.
Okay. Great answers. Paul, anything you want to add? I just want to say thank you. This was amazing. I learned so much, and I'm so glad it's all recorded, because I'm going to have to go back and review a lot of this, but it's going to be on the USES website. We will have, we answered all our questions, but if anybody has more to add for questions, please feel free to contact us at usesnnewyork.org. And Paul, Rogers, Mohammed, Kasamali. Thank you so much. Eva Hoskins, thank you so much for helping with all the back end. And thank you all for participating and sticking with us. It was quite a wonderful evening. Thank you.
Thank you.
Thanks, Maze. Thanks, everyone.
Thank you all.